The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation will provide information about patterns and sequence and how these apply to students with significant cognitive disabilities. This training is one in a series of training videos that supports teachers in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs. This training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. Patterns are all around us, from the clothing we wear to the repeating patterns found in nature and everyday routines. The ability to recognize and create patterns is also a basic math skill upon which many mathematical concepts are based. For instance, times tables, addition, and skip counting all require an understanding of patterns. Patterns provide us a way to see relationships and make connections between concepts. Giving students an opportunity to work with patterns in a variety of ways will help students develop these connections. We know from both research and experience that students with significant cognitive disabilities benefit from repetition, but that repetition should offer as much variety as possible. When teachers instruct using repetition with variety, the student receives multiple opportunities to work on the target goal in different ways. Repetition with variety also encourages cognitive engagement. Rather than merely memorizing, recognizing, or creating a single pattern in a single environment, the student must think at a deeper level because their developing understanding of patterns is being used in a slightly different way each time. Repeatedly finding patterns in different contexts can be fun and exciting for students because there are many different types of patterns that can be found. For example, in these pictures, you can see the pattern of vehicles that appears on the border of the rug and the pattern that appears with the posts and rails on the fence. Other examples of some beginning types of patterns students can look for include rhythmic patterns, color patterns, shape patterns, design patterns, patterns of position or arrangement, patterns of attributes, patterns of size, repeating patterns with numerals, and growing patterns. Each of these examples of pattern illustrates the variety of ways that students can come to recognize, analyze, and extend their understanding of patterns. The number of different ways that patterns appear in our everyday life make it possible to offer students with significant cognitive disabilities with the repetition they require while also ensuring the type of variety that is needed to understand the concept of patterns. This is important because understanding patterns helps students develop beginning concepts related to number operations, functions, and algebra. In addition to recognizing patterns, students also need to be able to predict and extend patterns. When we begin to explicitly teach students the concept of pattern, we often emphasize the patterns found in children's songs, poems, and movements. We also work with manipulatives that emphasize color, shape, size, and so on. The point is to offer varied and repeated opportunities for students to come to recognize a repeating pattern that is a group of anything that reoccurs, is predictable, and can be extended. For example, the picture of the two boys creating an A-B pattern using the triangle and square. Based on what they have created, another student could predict the next shapes in order to extend it. Teachers can support this learning by asking questions such as, how could you describe this pattern? How can it be repeated or extended? How are these patterns alike? Or, can you show me the beginning pattern? Predicting and extending a pattern can be made accessible to students with a range of abilities by asking them to show me what comes next. Now, just a quick word about growing patterns. In the DLM Essential Elements, growing patterns focus on linear patterns, which means that the pattern grows at a constant rate. In the example on your screen, as a new row of 1 is added, each of the other rows also grows by 1. Or in the numerical example, each numeral in the sequence grows by 3. Or in the numerical example, each numeral in the sequence grows by 3. Patterns like this are more difficult for students to recognize than simple repeating patterns. However, growing patterns should be introduced at beginning levels as one of the varied ways that you help students come to understand the concept that there are many different kinds of patterns. Pause for Activity 1. This next section of the module will address the patterns found in several domains of mathematics, including number sense, place value, and operations. The examples we are about to discuss do not reflect all of the possibilities, but they will help you think about other patterns and connections that can be made across the domains of mathematics. While not all of these examples are assessed directly in the Dynamic Learning Maps alternate assessment, building skills in recognizing and creating patterns and the ability to communicate about those patterns will help students develop the kind of language and thinking skills that are assessed directly in the DLM alternate assessment. Working on patterns across mathematical domains provides a rich and meaningful context in which both language and learning can occur. Finding number patterns begins when students start learning to count. Counting applies a pattern of adding just one more. If students count with their fingers or using manipulatives, they begin to understand the pattern of adding one more. A chart like this one, displayed here, can aid students in understanding how each consecutive number grows by 1. This is a pattern. Putting a block on the chart above the number 1 and saying 1 block, then adding blocks above the number 2 saying 1 and 1 more is 2. And for the number 3 you would say 2 and 1 more is 3. And so on as you reinforce the fact that adding 1 more leads to the next number. Exploring the patterns found in the base 10 number system provides students another opportunity to learn through repetition with variety to look for, see, and use patterns. The simplest form of a number pattern is a string or sequence of numbers that follows a logical rule or pattern. Here is the sequence of 1 through 6. The student is expected to indicate that 7 is the next number in the sequence because the pattern reflects the fact that each number in the sequence is 1 more than the previous number. A teacher might show this sequence of numbers and ask, "What's the next number in the pattern?" The student indicates the number 7. Then the teacher asks, "How do you know?" And the student indicates 1 more. It's important to notice that recognizing and extending this pattern requires the student to indicate the next number and tell how they know what comes next. When students learn to count from 0 to 10, they demonstrate one-to-one correspondence by pairing each object with one and only one number, and each name with only one object. For example, they learn to count 1, 2, 3, 4. But when we begin to teach about place value, we work with grouping and regrouping small amounts and work up to grouping by 10. Starting with smaller amounts means that the patterns repeat more frequently and therefore is easier to see and understand. Here we are grouping by 4. So the beginning place value chart would look like this. The first line at the top of the chart shows 0 groups of 4 and 1. The next line shows 0 groups of 4 and 2, and so on. Once the students have 4, they are grouped, and we now have 1 group of 4 and 0 ones. Then as more ones are added, our chart reflects the new quantity, 1 group of 4 and 1. This video shows an example of grouping by 10 and having leftovers. Activities like this one in this video help students begin to understand the pattern found in the numbers above 10.
Ready? 1,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, there's 10 spots? I'm going to give you some frogs. Tell me when you have enough. You put your frogs on. Put some frogs on.
1,
I'm going to give you some frogs. Here's some frogs.
2,
You want some frogs here? Okay. I want some frogs too.
4.
I'm putting frogs on my log.
5, 6, 7, 8.
Do you need some more?
There's more.
Do you need more?
Yes.
Here you go. Here's more.
8, 9, 10.
Isaac, let's count. You have 1 whole log full of 10, and how many left over?
Now?
How many left over?
This one?
And how many?
1, 2.
You have 2 left over, so you have 10, 11,
12.
12. So 12 has 1 whole set of 10 and 2 more. 2 ones left over.
Building on the concept of grouping by tens, a hundreds chart can help students learn to recognize patterns. For example, there is a pattern that 9 signals the end of a series and a different pattern at the beginning of each row, which involves combining a decade and a single-digit sequence, such as 20 plus 1, 20 plus 2, and so on. As students develop their skills in finding patterns such as 1, 4, and 7, and describe the rule as 3 more, teachers should model the language of addition. It is 3 more, and we can also describe it as plus 3. Repeat this with other addition number patterns, such as 3, 6, 9, or 4, 8, and 12, so that students get the repetition with variety to help them think about the patterns. Additionally, similar types of patterns can be found using subtraction, multiplication, and division. In our lessons, we need to be explicit about helping students link what they know about one pattern to another pattern. In other words, linking what they know about number sequence patterns to addition patterns and other operations. Pause for Activity 2. We are going to spend the last part of this module discussing the language of the DLM essential elements that focus on sequence. Arithmetic sequence is the first to appear, and it begins in 7th grade. An arithmetic sequence occurs when you add the same number each time as you move from one term to the next in the sequence. This fixed number is called the common difference for the sequence. In this example, the common difference for the sequence is 3. 1 and 3 more is 4. 4 and 3 more is 7. 7 and 3 more is 10, and so on. By 8th grade, geometric sequence appears in the DLM essential elements. A geometric sequence is one where the ratio between consecutive terms is always the same. In other words, you multiply by the same number each time to get the next term in the sequence. This fixed number is called the common ratio for the sequence. In the example 3, 6, and 12, the common ratio is 2. 3 times 2 is 6, 6 times 2 is 12, and so on. In the example 1, 3, 9, and 27, the common ratio is 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. Also in the 8th grade, the DLM essential elements introduce functions for the first time. Students are expected to use what they have learned about creating rules for sequences of numbers and applying it to two sets of numbers. A function is a mathematical statement that describes how two or more quantities vary in relationship to each other. A function describes a rule that matches two sets of numbers. For example, there is a relationship between the number of people in a group and the number of eyes the people have. One person has 2 eyes. 2 people have 4 eyes. 4 people have 8 eyes. The number of people has a direct relationship to the number of eyes. For every person, multiply by 2 to calculate the number of eyes. The formula would be P times 2 equals E. Much more information is provided about this in the module on functions and rates, but the example is provided in this module to help show the relationship between patterns, sequences, and functions. Learning about patterns begins at the very earliest stages of number sense and builds across mathematical contexts. It is important to support students in developing an understanding of pattern and sequence through repetition with variety, while building mathematical language that students can use to describe the patterns and connections they discover. For more information about the Dynamic Learning Maps Alternate Assessment System, please go to www.dynamiclearningmaps.org. Thank you for your participation.